Hi there, it's Mrs. Jenkins, and I'm here to give you some help with problems like number 4, 15, 31, and 32 on page 373 to 375. We're going to take a look in these types of problems at the opposite side. What I mean by that is when you have a triangle and you have an angle bisector. Our theorem states that an angle bisector in a triangle, like BD here, is an angle bisector. It's going to separate the opposite side here, AC, into two segments, and the lengths of these two segments will be a ratio that's equal to the other two sides. So in other words, in our example here, we can say that the length of AD is to DC as BA is to BC. So their ratios are going to be equal. Now if we take a look then and we want to find, well, what's the length of DC? We can simply substitute. We know that AD here is 5. So let's substitute in 5 for that, and DC is what we want to determine. We'll use the variable x. BA has a measure of 15 and BC has a measure of 18. So now we need to simplify and solve for x. We can cross multiply. I want you to take a minute and see if you can find the value of x. Once you've found it, just click continue at the bottom of the screen. To solve for x here, we can cross multiply. When we take 18 and we multiply it by 5, we're going to get 90. When we multiply 15 times x, we get 15x. Dividing both sides by 15 will give us our answer. X is going to be 6. So the length of this segment here is 6. Of course, the whole side there would be 6 plus 5, 11. Now I hope that taking a look at this example will give you some help working through your problems. Just remember, when you have an angle bisector in a triangle, it's going to separate the opposite side into segments that have the same ratio as the other two sides. Work well.